All right, for the rest of this section, let's talk about what we call expected value. Now, expected value is a term that we use to describe how much we can expect to make on like a given game. We have this formal definition of expected value here that says if in an experiment the possible outcomes are A1, A2, A3, A so and so, occurring with probabilities P1, P2, blah, 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 respectively, then the expected value E is given by this equation. But notice this is all of their outcomes times their probabilities. That's basically what expected value is. It's just the sum or adding up all of the probabilities times their outcomes. And this is the way we figure out whether a game is fair or not, because if a game is fair, then its expected value minus the cost to play should be zero. So it should, like work itself out and have a zero net there. Now, let's see how this works. Okay, we have an example here that says suppose we have 5 quarters, 5 dimes, 5 nickels, and 10 pennies in a box. One coin is selected at random. What is the expected value of the amount of money drawn from the bag? So what can you expect to kind of on average get when you pull one coin out of this box? Okay, well, we have some different things going on here. We've got quarters. We've got quarters. Let me just sketch this out here. We also have dimes. We have nickels. And we have pennies. Okay, remember, these expected value is where you add up all of the probabilities times their outcomes. So we need to figure out what is the probability for each one of these events happening. What would be the probability of pulling out a quarter out of that box? Well, there are 5 quarters out of a total of how many coins? 25, so that would be 5 out of 25. For dimes, there are 5 dimes out of a total of 25. There are 5 nickels out of a total of 25. And there are 10 pennies out of a total of 25. So now we have our probabilities. Now we also need to talk about our outcomes. If we pull a quarter out of that box, then we get 25 cents. If we pull a dime out, then we get 10 cents. If we pull out a nickel, we get 5 cents. And if we pull out a penny, we get 1 cent. So I would need to take all of my probabilities and multiply them times the outcome. So 5 out of 25 times 0.25 would be for the quarters, plus 5 out of 25 times 0.10 for the dimes, plus 5 out of 25 times 0.05 for the nickels, plus 10 out of 25 times 0.01 for the pennies. Now whenever I multiply each of these and then add them all together, we should end up with 0.08. So our expected value is kind of like an average. We can expect to get about 8 cents, sometimes a little more, sometimes a little less, but it's kind of an average. Now let's talk about as far as gaming, because this is where expected value really comes into play. Here we have an example that says it costs $2 to place a bet on a dice game. You roll a die, and if the die comes up with a 6, then you win $50. What is the amount you can expect to win if we do not take into consideration the bet placed? So we're not going to worry about the $2. Is this a fair game? And then what if we take into consideration the initial bet? So we have 3 different things going on here. Okay, what is the amount that you can expect to win if we do not take into consideration the bet? Okay, Well, so we've got different scenarios here. We can, if we get a 6, we win, right? So our probability of getting a 6 here when we roll that dice is 1/6. If we don't get a 6, then we lose. We don't get anything. So that would be 0. Oh, well, we would end up with 0. I'm so sorry. But our probability would be 5 out of 6. Okay, so if we happen to roll that 6, that's a 1/6 probability, we would end up with $50. Plus, if we do not roll a 6, that probability is 5/6, but we win 0. We lose. So when I multiply these together and add them up, we should end up with 833. So that's our expected value. Now the next question was, is this a fair game? Well, remember, in order for it to be a fair game, we have to have our expected value minus our cost to play. So expected value is 833 minus our cost to play was $2. If that ends up being 0, then we have a fair game. And in this case, it's not. It's $6.33. So this is not a fair game. Now, for the last question, let me draw a line here. It says, what if we take into consideration the initial bet? Well, if I get a 6, that's a 1/6 probability. And I'm going to win $50, but I had to pay $2 in order to get into the game. So I'm really only going to come out winning $48. Plus, if I roll not a 6, there's a 5/6 probability of that happening, and I lose my $2, so that's actually a -2. So when we multiply those things together and then add the answers, we should end up with $6.33. So that would be my expected value if we consider the initial bet.